Okay, I think we are live. Sorry for the delay. I had a problem here with my setup, but I wanted to welcome you guys. Thanks for joining me on this very first live stream. It's kind of a basic setup here. I got my laptop right in front of me to see the chat. Yeah, but I'm happy to live stream the PixelPump. And in case you do not know what the PixelPump is, I have prepared a small intro, and to be honest, I just finished the intro about 20 minutes ago. So yeah, let's just see how it goes today. We will be assembling a few boards using the new vacuum pump. And nice seeing you. I see we have 21 viewers, which is pretty cool for the first live stream. So without any further ado, let's go into the intro and I'll rearrange the camera setup so we can go ahead. Have fun with the intro. This is the PixelPump. It's a vacuum pump designed for manual picking and placing SMD components onto a PCB. It has the size of a small soldering station and is designed to sit on just about any electronics workbench. It's made for assembling hobby projects, maybe some client boards, or even to use it for your own Tindie store PCB production runs. A small and lightweight pen holds commonly available suction needles. Therefore, it can lift very tiny and also very large components. A thin and flexible silicone hose lets you forget that it's even connected. The tactile RGB button interface lets you choose between different modes and fine-tune settings on the fly. Two adjustable power presets make the PixelPump either quiet for tiny parts or powerful for larger ones. The included foot pedal ensures that you have both of your hands free for the actual assembly. And depending on the mode you are in, it either drops or lifts your part. The internal plumbing features a vacuum relief valve that quickly depressurizes the system once you let go of the foot pedal. The PixelPump also has a very fine filter that prevents debris from entering the system. It's visible from the outside and can be cleaned very easily. Then there's also a reverse mode. When active, it pushes air out of the nozzle instead of creating a vacuum. This lets you clear out things like solder paste that you might have sucked in by accident. The PixelPump will be fully open source, meaning its schematics, source code and STL files will be available on GitHub once the project is finished. The pump is built and assembled in my shop here in Germany. It will be delivered in a fully 3D printed PETG enclosure. I'm currently running two Prusa Minis, which are dedicated for the PixelPump production. So in this live stream, we'll take it to the test and assemble 15 Pico Planets to simulate and demonstrate a small production run. The Pico Planet is a nicely designed board around a SEMD21 microcontroller. It has 3 touch buttons, a USB-C connector and RGB LEDs. BleepTrack, who designed the board, kindly provided the Pico Planet Gerber files for this stream so I could order the PCBs and components. All of the boards we assembled today will be donated to her and will be available on her Tindie store. The PixelPump will be entering crowdfunding very soon, or depending on when you watch this video, it'll hopefully be already available for purchase. To find more info about the PixelPump itself, please look into the video description. Okay. Nice. So now you have seen what this is all about, and I rearranged the camera to show my workbench. So just an overview, we will today be making a few of the Pico Planets PCBs. Just please let me know if my audio quality is clear, if you can hear me. Let me maybe So let me just fix one thing. I see it's a little overexposed here and maybe not perfectly in focus. Okay, I think that's better. Okay, so what we'll do is we'll try to make 15 of those PCBs. And what I have here is right next to me, I have the stencil printer. And I just rearranged it so it fits. I rearranged it before the stream so it fits, so we don't have to fiddle around here. And I'll just say, let's go and jump right in, guys. So this is the Pico Planet. If I put it here, it should actually line up, and that's, I guess, nothing you can really see, but you have to trust me on that one. Let me just put on some gloves so we don't get in touch with the solder paste. And by the way, did you like the intro? I kind of felt the need to make one to, yeah, just in case people don't know what that is, and I kind of like the idea of having an intro in a live stream. Okay, so I am using mechanic solder paste here and just a steel squeegee, which is pretty good because it's kind of thick and really tough. So let's just go ahead and mix some paste. And it's always a good idea just kind of, you know, this is maybe a week or open for a week now, so it's kind of a good idea to mix and match the solder paste with the included flux. So let's just grab a big chunk. So since the Pico Planet is only maybe 3 centimeters wide, I do not need the entire squeegee. But if I kind of just distribute it here, it's way too much, but it doesn't matter because I can take the remaining solder paste and put it back into the housing or into the box when we are finished. So let's put that here and kind of make our first board. Which should be good now. I really like the big squeegee. Let me just try and focus that. Yeah, it's a bit tough to see, but looks kind of good, looks enough. I mean, when you reflow a board like that, you don't have to be 100% accurate with the solder paste because it's kind of reflowing into place once, once it's in the oven. So let me slide you back to my main desk. And this is kind of a first slider setup here that I can use one camera for the stencil and also for the placement. Okay. Wow, we got 51 viewers. That's kind of cool. That's really cool. Okay, so we have the pump here, which was introduced in the intro. And I don't know, but maybe when people were joining later on, we could play the intro again, maybe at the end of the stream. I don't know, maybe. That's a good idea. If you want to see it again, please leave a comment or a chat message. Okay, so we have a few components. I just made a cheat sheet here that tells me which component has to go in which place. And it's only a few, so I got these SMD magazines. Maybe it's worth talking about them as well. So this is the version 2. Some of you may have seen or may have even downloaded and printed the version 1 of them. It is kind of to store SMD components and use them for placing, picking and placing and stuff like that. So just to make one thing clear, the PixelPump is actually not dependent on the SMD magazines. This is kind of a separate project, and you don't have to use magazines like that at all. You can have, I saw Xeon, like the Unexpected Maker, having a kind of carousel thing going on with the components inside. It's perfectly fine if you prefer something like that. I kind of like those. I mean, I designed those, I obviously like them, but I like them because the storage is pretty cool. I can just put them in a box. Let me show you one of those boxes. So this could be a box like that. I have plenty of components in here. They're all labeled. And depending on the project I'm working on, I just pick the ones I need for that and click them onto one of those rails and go ahead with the project. So there's no big time for setting up a project. You can even leave, like this here would be the PicoPlanet project. Like if I would do these boards on a regular basis, I just leave them on that rail and maybe label them PicoPlanet or something like that and put them in the shelf and just bring them up when I want to do more boards. So yeah, well, just maybe before we start, one or two key features maybe of the magazines. So what's important here is those are like spring loaded. That means they always have a constant force on your SMD tape. That means if you pull them out and peel off the plastic covering and you put them back in, they'll be resealed. So if you put them in the shelf, you'll not lose any components. They'll not get stuck or something like that. Also, if you have them in here and you pick them with a tool like that, and even if you bump the tape slightly, it'll be fixed much better than the version 1 because it's held by the spring-loaded contact. Yeah, but that's kind of a separate project. These here are meant to be injection molded at some point, so that's going to be a separate maybe crowdfunding project or something like that. But I actually thought about, if you are interested, I actually thought about starting just to sell them as a 3D printed, project. Maybe to, yeah, just to try them out. The rail is 3D printed, obviously, and it's also filled with sand. So this could be a project that I might start selling on Tindie or through my own web shop or something at a, yeah, if you guys are interested. But that's not for today. Today we want to build the PicoPlanet. So let's start without talking too much. For the components, we have a couple of 0603 resistors and capacitors, and also an 0402 component, which is, of course, doable with a machine like that, but it's kind of dependent on your personal capabilities. Like if you have good eyes or a good microscope, you can maybe go even smaller. But I kind of felt that 0402 is, yeah, it's kind of the bottom line that you want to do with such a device. But okay, let's start. One thing I have to do is I'll just take my camera with me if that's possible, because my oven is kind of at the other side here. So you can see once what I'm doing. This is my oven. It's kind of a modified T962A oven. Most of you probably already know. And what I do is I kind of preheat it. So if I go to F3, I preheat it to about 90 degrees. It's hard to see display, I know, from the camera, but I preheat it to 90 degrees so I get consistent results. Because if I start a project from the cold oven and it's kind of okayish, and I do the next one in a preheated oven, the results may change. So that's why I kind of preheated and why I calibrated it in a preheated state so it makes reproducible results. So let's preheat the oven, and while it's doing that, we can assemble our first PicoPlanet. Just tell me maybe one thing, is the angle in here, is it kind of okayish for you to see what I do here? So maybe just leave a chat message or something telling me that's fine. Is it in focus? Okay, so maybe let's start. So we have R1, R2, which is 5.1K. So what I do here is the second magazine here is the 5.1K resistor. And what I do is I grab the tape up here with my one hand and hold the pen or whatever tweezers you have in the other hand and kind of just advance the tape with my right hand. So if I advance the tape right now, you can see that it kind of starts sticking out and exposing fresh components. So when I go ahead now is, I just hit the foot pedal. I'm set up here. Maybe I can show that again. So I think we just, sorry for not starting with the project, but we have like two modes in here. Maybe just as a hint. That's the lift mode, is the one on the top of left. And if I hit the foot pedal right now, it'll start sucking. And if I let go, it'll let the part go. Meaning I have to hold the foot pedal while I want to hold the part. So I think that's kind of a personal preference thing, because I have a second mode, which is drop. And now it is kind of aimed. If I hit the foot pedal now and I just release it again, it will keep running. And now I can grab a part or lift the part. And if I hold the pedal, it'll stop. So it's kind of pressing the pedal to hold the part, or pressing the pedal to drop the part. It's kind of the I guess personal preference. But I just leave it as in the lift mode, so it'll grab the component as long as I hold down the foot pedal. Okay, so finally, let's start. So we have R1 and R2, 5.1K. I'll bring you in closer a little bit in a while, because we have 15 boards, so you can see all the different angles. So I take the 5.1K resistor. I have it here on my needle right now. It's hard to see, I know, but I'll place it at R2. Oh wow, I got shaky hands here. And R1. So that's kind of the first component. And I'll just go ahead in one or two boards and just go through one of the boards without talking, so you can see kind of the speed that I'm at with using the device. But right now I'm just kind of talking too much. So we have R6, which is 1K. I'll advance the tape with my one hand and pick it with the other. And of course, because we have a foot pedal, that's kind of really sweet that I have both of my hands kind of free. So that's the 1K, which I need 3 times, which are the ones down here. 1, 2, and 3. Wow, I got real shaky hands. Okay. Then we have C3, which is 1 microfarad. So usually you'd have, oh, where is it actually? C3 is 1, oh yeah, it's the second one here. So usually you'd have something like IBOM open, which tells you where the components have to go. This is kind of just a crude setup here with the paper sheet, but I mean, it works. And if you do the same boards over and over again, you obviously know where your components are, so you're even faster. So 1U is down here. I just hope this guy works here, because I'm talking so much and kind of losing concentration on where the parts go. So that's kind of 1U here. 10U, I think is the small one. Yes. So this is one thing with the magazines. If I can show you this. Here, these are the 042 components. And usually those are so damn cheap that if you go ahead and purchase 1,000 components, you can sacrifice the first, I don't know, 10 or 20. Just pull them out so you can peel the plastic tape long enough so it sticks out at the end. I kind of did that on purpose here to demonstrate what I do in such a case. I'll just go ahead with my tweezers and lift the tape here and grab a component from there. And once I have advanced the tape long enough, or much enough, how do you say that? Yeah, long enough. So I just bend it backwards and so it kind of sticks out here. So that's just one thing to keep in mind. Usually I think 1,000 resistors, 0603 is like, I don't know, $5 or something. So you can easily sacrifice maybe 10 or 20 to get the tape. So this is the small one. That's a 10 microfarad one. 100 nanofarad one. So I'll just place this one before my hands get shakier even more. Okay, so I got it here. I mean, this is not obviously something you cannot see, but with the next board, I'll bring you up a little closer. Okay. And also, usually I do not sit on the table like this. I am like sitting more straight, but if I do that, you cannot see anything. So usually I see it better, and I'm also quicker. Okay, so we have the 10 microfarad. We did not put that here. Where is the 10? Where's the 10? Did I miss one magazine? Wait, so we have one. Yeah. Yeah, I kind of lost one of the magazines. Where did I put that? Just give me 1 second. Now I know this is kind of stretched out a little bit, but I will stop talking so much once we are finished with the first board. Oh, I got it. It's here. So if I had put that back into the shelf, I'd be, yeah, I'd have it right away. So, okay, we have the 10 microfarad one. Let me grab that and put it C4, which is up here. And actually we're almost done with the board. And C1 also. Okay, 1010. So we have R6, which is 1K, which is here. And usually you still need tweezers, right? So the vacuum pump is not a replacement for regular tweezers. You need them all over the place to kind of rearrange things and grab components and, you know, do stuff. So that's not a replacement, but it's kind of yeah, you need the tweezers from time to time to place components. Okay. So we got all the passives. Now we have the LEO. And I did not advance the tape wide enough, long enough, far enough, I think far enough to kind of put it up here, but we will come back to that later on. So I'm still using the small nozzle here for the little component, which is plenty fine. And what I can do right now is if I want to change the orientation of the part, or if I need it in a different orientation, I can go ahead and just rotate my vise because I have a hand free, or I just drop the part somewhere else, and without activating the pump, I'll just rotate it, which is also a pretty clean way to do things. Okay. Yeah, I'm left-handed. That's true. R2 is D2, yeah. Okay, so we have the LED, and I have to cheat a little bit here because I am not sure about the LED orientation again. And that's something, if the boards I make myself, and I plan to assemble with with the vacuum pump, I usually make a silk screen addition for like just a drawing of the LED, so I always see how it should go. So let's see, it has an edge, yeah, on the bottom right, okay. So let me grab that. And it's kind of awkward to sit here with the foot pedal so on the right side next to me. So where's the edge? The edge is up there. Yep. Okay. And I do have a microscope so we can actually see the part under a microscope once we had it in the oven. Okay, so then I'll switch to the SEM-D21, which I also showed in the intro video. I need the bigger nozzle, so I just change it, grab this part, and also I have to rotate it here. So I just put it somewhere else, rotate it how I need it, press the button again, and place it. Okay, so last component is a USB-C, which is not in a magazine because it's a pretty wide strip. Yeah, this is something I just lay somewhere and use it when I need it. And for the USB-C, I kind of could also use just regular tweezers, but I'll go with the pump. Okay. All right, so I think we are ready with the first board. Let's take a look at the placement. Yeah, I think the LEO is just a little not straight enough. Starting off sounds like a cow. Yeah, well, indeed, actually. Well, it's kind of, it has the sound, and once you block or suck something, it kind of, the RPM increases. Okay, I think that's good. Okay, let's take a look. Yeah, so this is the, let's zoom in a little bit. So that's my placement right there. I think it's all right. The LDO is a little awkward, but that's gonna be straightened out in the oven. So let me just take you with the camera and bring you over to the oven where you can put in the board. And while this board is baking, I'll just make the next board a little faster without explaining everything. And I think we could, if you like, we could run down a few of the settings the pump offers. You can kind of tune the display brightness and stuff like that. Okay. So, and I definitely need to increase or improve my camera setup here. So let's put the board in here, close it, and start the reflow profile. That's gonna take about 7 minutes. Let me see if I can. I don't know why it's so greenish. Kind of turns blue and then turns green again. I don't know. Yeah, it takes about 7 minutes for a board, and usually in a project like that, I just make maybe 5 boards. This one would actually also be perfectly suitable for having a panel, because the components are only at the top portion of the board, and if you have like 5 next to each other, you can of course assemble them way faster. So this time let me maybe bring you down a little closer. Or we have to, no, let's go up again, because we have to kind of make the solder paste first. All right, so back to here. Let's put in our next board. Take the squeegee. Should be good. Quick look. Yeah, I think that's all right. So this is kind of the workflow, right? So with when I am doing that on my own and I do not have to rearrange a camera all the time and do stuff like that, it's obviously a lot easier and faster. So let's bring it in a little closer. Maybe like that. So let me just check the chat real quick if there are any questions. Yeah, we all just came for the RGB LEDs. Yeah, well, I'm sure about that. Those are pretty cool. Okay, so let's make a board maybe a little bit faster, so you can see my placement close up, which I'm not sure if it is beneficial or not. Okay, so we have, well, this is even more awkward right now to have the camera in the way. Okay, so we have 10 microfarads, which is up here. Okay, we have 1 microfarad, which is the next one. We have 10 again, which is here, 5.1K. Um, 1K. And 1 microfarad again. And you're kind of optimizing from board to board, like the which one you do at which time. So now the 0402 one, which I have to pick up with the tweezers again, and now you can see how inconvenient it is to not have the components, like to not have the tape stick out that much, so you can extend it with the second hand. All right. Then we are done here. Let's put the LDO, which is also again used with the tweezers because you're not sacrificing like, I don't know, how many LDOs. And by the way, I'm on low mode right now, which is the low power setting. Let's put it in high mode. Let's make it while it's running so you can hear it. It's low. It's high. Oh, we were in high mode. We were in high already. Okay. Never mind. Okay, that's here. So then we have 3 passives left and the LED, and that's it. That's 1, 2, 3. Okay, now the LED and we're done. No, the IC and USB. Not quite done. So let's change the nozzle again. And by the way, this is a lure lock slip fitting. And this also takes kind of like every nozzle you can get with, you know, you can also put in something like this with a plastic kind of covering or a silicone tip. I don't know where you want to use that. Because I don't know any SMD component that needs something like that. If you want to place a complete ESP32 module or something like that, you could, or I just use tweezers instead of doing a nozzle change. But yeah, I just need like the kind of the green one, which is the thicker one for stuff like the USB or the SMD. So we have it here, and we can also use the board to rotate it, of course. Just put it like that with the dot facing up here. That's it. Where's my USB here? USB-C. I usually like the USB-C kind of things. I just know how many boards I want to have, and I just peel off a few so I have them on my desk ready to be placed somewhere. Okay. I hear the oven cooling down, so I think we're almost ready for the next board. Okay, done. That's it. Focusing is a little hard. Yeah, so let's put it aside. We are faster than the oven. And take the next one. And I don't know, you want to see me put up the solder paste all the time? Maybe we can do a close-up of that as well. I cannot focus. Why cannot I focus? Oh, I'm in manual focus. Okay. Let's put in the next board. Let's put in some solder paste. And if you'd had a panel, oh, that's the oven is finished. If you'd had a panel like that, you would obviously also, you know, paste 5 boards at a time. I think that's a little much paste because I did it twice. So let's see how this board kind of performs. I'll just change, or I just pick up the board in the oven. Or you know what? Let's just let it cool down until we have 5 boards done, so we can bake them all at the same time. Okay. Just open up the tray. And I know it's a little hard to follow here because I only have one camera, but I mean, I do have a second camera, which Stefan from CNC Kitchen kind of lent me. Also, the microphone that I'm wearing and all that stuff is kind of from Stefan. So vielen Dank, Stefan, if you're still here. So what I want to demonstrate here is like the benefits of having such a pump. In my mind, are that you can place components a lot faster. And why would you want to do that? I mean, the pump is clearly not meant to be a replacement for automated pick and place machines or stuff like that. Because I mean, if you are doing mini boards, like mini boards, you're not doing them by hand. But if you maybe run a Tindie shop or have a client project with like 10 boards or something like that, I think it makes a lot of sense to have, you know, some system like that, because you can run through the 10 boards pretty quickly. And maybe also if you have a Tindie store or something like that, you could have maybe 5 or 10 products that sell, I don't know, maybe 5 each a week or a month, or I don't know. And if you have like one of this rail, or maybe a rail per project, you can build 5 of project 1 and 5 of project 2. And yeah, that's kind of the benefit. Like if you had a pick and place machine for that, where do you put it if you don't need it? And also, I think the times to set up the pick and place machine for like 5 projects in a row is kind of a little bit of an overhead. I mean, of course, you have to prepare the magazines here, but if you do them once, one of the magazines can hold close to 1000 0603 components, so you can do a lot of boards with that. And I just think that's kind of a cool system to get stuff done with picking and placing. Let's take a second and talk about the pump again. Let me try to focus that so you can maybe see how like big and large or small it is. It's about the size of just a smaller soldering station. And can we focus here? Yeah. So you can put that on your desk, and it's kind of not in the way all the time. And you have it ready whenever you need it. And just for the matter of fact, it is almost half a kilo heavy, which is kind of heavy for a device that small in a, of course, plastic enclosure. And if you can see the base down here, which is entirely filled with sand, so this kind of really sits at your desk like a rock. And also, if you put it somewhere and you press a button, it'll not move, right? You can press the button how hard you want or how hard you need. I mean, you can press it like really hard, of course, but and it'll switch just as you like it to do without, you know, pushing any further or away from you. So maybe just let's run down through a few menus. I kind of thought about having the ability to tune settings. For example, if we are in low mode, if I hit the pedal right now, you can hear that it's different from the high mode, right? But what if low mode is just a little bit too low or too high for your taste? So you just go ahead and long press on low, and now you are in the low setting adjustment mode, if you want to call it like that. So you can now use low and high to increase or decrease this power setting. So you just go ahead and hit low or high until you like it, and you can cancel with the red button or save it with the green button. And that's how you can adjust a setting here in the PixelPump. Also, if you have a dark workspace, this one here is pretty bright. If you have a darker one, and you can tune down the LED brightness, you can go ahead and long press on lift, which goes into the brightness setting, and also you get the common scheme here. The green one, or the trigger button, turns green and acts as a save button, and the reverse one goes red and acts as a cancel button. And the low-high have decrease and increase. It's hard to read, I think, from your perspective, but it's decrease and increase to decrease and increase, obviously, the setting you are in. So right now, if I hit low a couple of times, you can see that the buttons are getting darker. Yeah, and that's kind of how you can tune settings. You can also go into update mode, which it's powered by the Raspberry Pi RP2040, which is obviously just exposing the device as a USB-C mass storage. So you can go ahead and, independent of your platform or of your operating system, you can go ahead and yeah, put in a new image with a firmware update if that's necessary. Yeah, that's kind of it, actually. That's how it works. And I kind of used it for a couple of boards now, or actually pretty much boards now, and pretty much boards now. And I'm super happy with it. Okay, so let's go ahead and make a new board. And I'll just maybe focus on the magazines for this one, so you see everything from a different perspective. Let's go in a little closer. This is how they look. Okay. So where's my cheat sheet? So 5.1K. So what I do is, I hope you can see that, but if I pull the tape here, it'll expose 2 new resistors, or I pull it so far that I am able to pull out these 2 resistors. And just in case I need to put them back into the shelf, I just push them in, and the force of the spring will force it upwards, so they cannot fall out or you know, clog in there or something like that. Yeah, so let's expose them and place them. So I'm in my newly adjusted low mode, which is plenty fine for 0603 components. Oh, the solder mask is pretty off right now. Let's just hope this one is working. And again, I mean, I'm kind of not 100% concentrated and focusing on how nice I apply my solder paste, because I'm on a live stream with the cameras in my way. Usually this is kind of easier to do. Okay, so but it's a demonstration anyway. So the 1K resistor is right here. Let's take that. And you can see how quickly you can advance the tape and gain access to components. And I think that's kind of cool, because they're obviously always oriented in the right, you know, they're never upside down, because this is how pick and place machines actually pick the components, of course. And also all the tapes you get are kind of optimized for something like that, because they are in a tape form with which has, or they have the peelable plastic kind of cover. And yeah, so I think it's kind of cool to have a magazine like that, which is pretty much how a pick and place machine would pick or store components. Yeah, one last note maybe about them. If you do a board that has maybe 100 LEDs and that's the only component on the board, you obviously do not need to pick them from a magazine. You maybe just go ahead, take the magazine and dump a few. You just have to kind of pull the tape here and put it upside down, and you can dump as many as you want into some cup, or you know, just in front of you, which is sometimes helpful if you only have one single component. You don't need the stack here. But I still think the storage in a magazine is kind of beneficial, because you can have them in a shelf and you can have them easily accessible. Like all the trays you have and stuff like that, you'd kind of have to, if you're finished with your project, you kind of have to dump them back into the ESD bag, or you never, you know, kind of know where they are or how many you have left or something like that. So I kind of still would use something like that. Of course, it has its limits. Like the USB-C connector right here is just too wide for such a magazine. And I'm thinking of making wider versions of the magazine, because this one is kind of 15 millimeter, or made for a 15 millimeter tape. Yeah, you might have wider tapes, you know. Okay, so, wow, so much talking. Okay, so C5, we need 1 microfarad, which is here. Oops. Take it and place it. So now we have the 100 nanofarad one, which is tweezers. Now you can see me lifting up the tape, advancing it a little bit. So I have the 0402 cap here. Okay. Okay. This is also the reason no normal one builds a Voron V10 or ANT PCB maker. Oh, ANT PCB maker, oh man, on a live stream. It will be demonetized. Because what? Because of what? Did I swear or something like that? I probably have. But I actually do not care about demonetizing the video. I'm not intending in, you know, like the ad revenue is not even closely in my focus for this video. I want to demonstrate the unit, and if that's, yeah, demonetized, then so be it. Can it handle 0201? Well, it can, if you can, kind of like. So if you, this is a 0.3 millimeter nozzle. I think there's one smaller one you can get, but it's kind of dependent on how you, like how steady your hands are. And maybe you need a decent microscope for that. For 402, I do not place with a microscope. My eyes are okay. I do not have to wear glasses. But I think with a microscope, why not? I mean, should be doable. Okay, so we have placed this entire row. Let's pick the LDO, which is here. And I think this tape is kind of almost far enough to... Okay, so right now this is a bit low in the low mode, so let me switch to the high mode so I don't have to change the nozzle. You can do obviously two things. You can, like generally in a vacuum system, if you need more lifting force or something like that, you have to increase the diameter of the circle that is kind of, you know, acting on the part. So if you had a wider nozzle, you need less vacuum to lift the equal amount of weight, or you get more lifting capacity with the same vacuum. So what I do here is I have it in low mode because those components here, they are like, I don't know, 0.01 grams or something like that. And I just go into low mode because the device is a little bit quieter, and I think it's, or not I think, I'm sure it's the lifetime of the pump and stuff will be a lot longer. And you just don't need it. And now, right now, I could have changed the nozzle to a thicker one to pick up the LDO, or I just go into high mode and pick it there. Okay, so C1 is 10U. So maybe you saw a couple of perspectives right now. If you give me a hint which one is kind of the, you know, most or the nicest one to watch, just write me a message or just leave it in the chat so I can, yeah, I can adjust it. So that's 1 micro. It's right here. Then we have 1K 3 times, which I can expose 3. And I only expose as many as I need for one particular step. Otherwise, if I bump into it or something like that, I will not spill them. Okay, LED. And thankfully the LED orientation is also is correct right off the tape, so that's kind of nice. So 2 components left, which is the USB, and for that I'll just change to a thicker nozzle because even in high mode the very small one is not enough. Okay. Oh, and yeah, one thing that I want to say, I said it in the intro already, but the pump has a few valves in it, and those do different things. For example, there is a pressure relief valve, and if you, I hope, let me bring up the unit closer. When I press the button, I hope it's not going to be too loud, and I let go, you can kind of hear the valve clicking 2 times. The first time is opening it, so it dumps all the vacuum, so your part kind of drops to the floor or on your board. That's better. And the second one is it closes again for the next cycle. If I go into reverse mode, you can hear a lot more clicks. Let's do that maybe. And that's because it has 3 valves in it, and it has to rearrange many things inside to be able to push out the air. It has to open up the exhaust valve and close up the inlet valve and stuff like that. And yeah, but it kind of works, and we can demonstrate that later on if you want, and just suck in some solder paste and try to clean it out with the reverse mode, because that's what it's meant. What it's meant for. Like if you place if you fiddle around here and you suck in some solder paste by accident, you'd have to change the nozzle on other, like, you know, products. But here you can just go into reverse mode and push the solder paste back out, so you are, you know, up and running again. Okay, so last component is
the Atmel. Okay, and we are done with the second, or the third board actually. But I did a lot of talking. Sorry for that, but I think it's interesting to know how the device works and kind of show off the system. So these are the two boards. I'll just put them in the oven, and grab the one that's finished so I can show it to you. And I don't think I have to take the camera again to the oven, right? Because it's, you know, it's just changing the boards. So 1, 2. Okay. And start. I of course forgot to start the preheat again, so we are in a 30-degree oven instead of a 90-degree oven, but let's just see how it goes. So let's look at the chat. Aren't they already on Thingiverse? Yes, well, that's kind of the version 2. Let me bring up a version 1 as a comparison. Yeah, so this one here. So this one, and that's my chair you hear squeaking. This is the version 1. And the version 1 is kind of what's on Thingiverse. And here you can see it is, of course, open in the side, which is not the case for the version 2. So your tape can fall out. It's if you fill it up like that, it's not going to fall out. Even if you drop it on the floor like that, it's not going to completely go out. But there are components in a plastic kind of like the LEDs and stuff, and if you only have a few ones like that, and they will of course not hold in there. And this is another benefit of the version 2, which has a spring-loaded, you know, adjustment thing here. Let me just show how you can load them. So this would be the LEDs. They are labeled on here, and you can go ahead and just pull down this lever here, which is kind of the counter force, push it in. And when you let go, it's kind of fixed. It's not going anywhere. Even if you have just a few components, it will not go anywhere. And in a system like the version 1, you obviously don't have that. You have a fixed gap, which is problematic because if you have a loose component and you pull it out, it's kind of going upright and blocking the channel, which is a major downside of this. And also, you'll never have a perfect fit. And if you have just a few components, maybe I have a magazine here. Yeah, like here, for example. So this one here only has a very short tape in it. And if I pull it out all the way, it's kind of already starting to get floppy here. And that's not what you want, obviously. And also, if you push it in, this one is kind of tight, but if you push it in and it's not that tight, it'll push itself out again because of the spring force of the tape itself. And the new version kind of eliminates all those errors. Also, this one here had the plastic tape come out at the back like that. So this is kind of coming out here instead of in the front. And the thing is, I thought it's cool to pull it here because, yeah, that was the first idea. But the problem is those components in here, they will be exposed even if you push the tape back. And in the new design, you cannot see it here. Maybe I have an open one. It'll push against, and even the portion of the tape which has already been lifted, the tape will be protected and covered. And also the tape will get peeled at the very front, so you only peel the components you really need. Yeah, so that's kind of version 2. The form factor is the same, so I can put the version 1 magazine onto the same rail as the version 2. It's kind of not as wide as the version 2, but I think that's not a downside. And also, yeah, this one is a very old version with the spring-loaded lever. The new ones have a compliant mechanism. And also the injection molded ones, I mean, this is 3D printed, but it will be injection molded at one point. They will have the compliant mechanism, spring force. Yeah, so that's version 2. The best thing is kind of the spring-loaded cover in front, if you want to call it like that. Let me actually see if I have an unassembled one here. Oh yes, I do. And I'm already having a feeling that this stream is going to take very long. Okay, so this is how an open version looks like, and you'd have, are we in focus? The thing is, my camera is not autofocusing continuously when I'm not recording. Okay, this is the lever. This rides in this slot here and kind of pushes the tape against the upper wall. And so you'd always have a constant force against it, which makes it stiff and sturdy and also protects the parts from falling out. Also, this version, and that's kind of actually one of the bigger benefits, it's made for a 10mm tall part as well. So if you had large capacitors or stuff like that, you'd be online with the same version of the magazine. The old ones had a fixed gap you should have to choose, or you would choose when you start 3D printing it. So you measure your tape and print the right one. And here you have one version that fits it all, basically. And then you just cover it up with the lid. In my case, the 3D printed ones are kind of glued in place, but the final version, the final injection molded version, will have a press fit. Yeah. So those are the magazines. And also, one thing that I haven't started, but I'm planning on, is right now I'm kind of labeling them manually with just a label, you know, label maker, or how you call that. But I want to do a sticker sheet that has, I don't know how many, 50 on one sheet. You can just put them into your printer at home. And you'd have an online tool that you could just upload your BOM or something like that, and it would generate all the labels for you, and just hit print and stick them onto your magazines, and that's it. Yeah, so that's kind of the magazines kind of project. Okay, so we have 3 boards. 2 of them are in the oven, 1 is finished. That's not even close to 15, but I just rush through 1 or 2 boards to demonstrate how how fast that usually is, or how fast I can go with the camera in front of me. So are there any questions? We still have 47 viewers. That's awesome, guys. If you like the project, I'd be very happy to see a thumbs up or a comment. I think you cannot comment right now, right? Because it's a live stream, you can only chat. Okay, so let's go. Let's make another. Oh, by the way, this is the one we just had out of the oven, which looks kind of all right to me. We can throw them under the microscope at the end of the stream if you want. For now, I just leave it like that, because if I'd now test every single board, we'd need a lot more time. But yeah, let's maybe show the test jig. I think that's kind of interesting. So I made this little jig here, which has spring-loaded contacts, and you just go ahead and pop in your board like that. That's it. And you hit the USB key. You plug in the tie guard, which is a board you should definitely consider buying because it's awesome. It's a universal protocol, you know, board that can do the SPI bus, the I2C bus, and also Cortex, JTAG, and SWD, which I'm using right now. It's configured for SWD, and it has the pins exposed through the cable here and through the pogo pins. And that's kind of, if we take a look at that, that's kind of looks like a cell phone or something like that. The pins are on the bottom side of the Pico Planet are here, and you just put it in here, push it down, and the spring-loaded contacts are kind of pushing it up against the lever here, which is also spring-loaded, so you have a nice little flasher. And this is something, if I'd make the Pico Planets for my Tindie shop or something, such a device will make it a lot easier. You could have an automated script on your PC or Mac or whatever you have, and test the board, flash the board, put the bootloader on it. I do not know what Bleep Track. I think Bleep Track is using a PCBA service, which also flashes the firmware. I'm not sure, actually, but I'll send her this unit and just as a gift. Maybe she needs it, I don't know, but for sending me the Gerber files for this demonstration. Okay, So let's go ahead and make a new board. And I think we should just make 2 or 3 at the same, yeah, let's make 3 at the same time. Where's my stack? Here. So, number 1, let me just confirm that the stencil is still in place correctly. Yeah, it looks kind of cool. So let's take the squeegee. Maybe we need some more solder paste. Actually, we do not. I just have to rearrange or I don't know, re-put the solder paste on here because it's plenty. Okay. Yeah, that's better. Okay, number 1. Let's check. Looks good, maybe a little too much. Let's make the second one. It's all right. Maybe a third one. Looks good. Okay, let's make 3 boards in a row maybe. So we have 6 boards done. Yo, I just saw, wow. Thank you much for the $50 donation. That's very generous. How much approximately do you think the PixelPump might retail for when it's available? Thanks for sharing so much of your great work as open source. Yeah, well, you're welcome. And in case you missed it, this project will be open source. The PixelPump itself will be open source. I will release the STL files, the schematics, and also the source code, which is written in MicroPython at this time because I absolutely fell in love with it. And I just do not see a reason why this should not be programmed in MicroPython. Yeah, I think the machine will be retailed for something maybe 300, 350 tax included, something like that. That's kind of the current price. I did not run the final numbers, but that's kind of what it might retail for. It will come with a foot pedal and with the hand pen here, but it's kind of be somewhere in that ballpark. Yeah, and if I look at the products that are out there, oh yeah, that's maybe one interesting thing as well. I kind of built that because I haven't found anything that I wanted to actually use. There are, of course, the fish pump kind of solutions, which is just a Amazon pump with, you know, some crude syringe and a tip, and that's perfectly fine. I mean, I use that all the time, or I have been using it all the time. But I just wanted something more permanent with a little bit of, you know, settings and stuff. And yeah, and that's why I kind of came up with a design like that. I wanted to have a pen that attaches. I wanted to have a foot pedal. And by the way, this pump supports 2 foot pedals. Maybe I can let me show that. You can daisy chain a second foot pedal here. I didn't install the switch yet, but you can switch between A and B here. You can daisy chain a second one and then go with 1 cable up to the pump. Yeah, there's 1 cable for the foot pedal here. And the reason for a second foot pedal will be you can do with it whatever you want. You can configure it to change modes. You can configure it to switch to between low and high, or maybe into reverse mode or something like that. But kind of the coolest thing that it will support is the second foot pedal will be used for switching to the next part in iBomb. And that's kind of the coolest thing ever, because if you are making boards and you have the iBomb plugin, I hope you know what I mean with the iBomb plugin. Maybe would be really nice if somebody would post a link or something to the iBomb. It basically generates a nice list of components that you have on your board, and when you assemble them, you see where they are on the board. So you see, okay, C1 is a 10 microfarad capacitor, and you get an image from your actual PCB where you have to place that. And when you're done with one component, you can tick a placed check mark, and it'll jump to the next row. And yeah, it's out of focus, I'm sorry. Let me fix that. Yeah, and that's kind of a purpose for the second foot pedal, because I wanted a second foot pedal so I don't have to hit any key command or use the mouse or something like that. I have a monitor in front of me with the iBomb plugin, and I want to hit the second foot pedal and just jump to the next line, which is absolutely increasing the productivity. Yeah, but the possibilities are basically endless. It's an open source project. If somebody has a better idea for the second foot pedal, you know, it's an open source project, and people can use the foot pedal for whatever they like. But I think the main purpose will be for switching to the next part in iBomb. Okay. You know what, guys? If you don't mind, I'll just grab myself a glass of water, because I totally forgot to do that. And I don't know how many of you are new here, but I just put in the intro once more so you can see the PixelPump again with its features and stuff, and I'll be back in a minute with a glass of water. So, see you in a minute.
This is the PixelPump. It's a vacuum pump designed for manual picking and placing SMD components onto a PCB. It has the size of a small soldering station and is designed to sit on just about any electronics workbench. It's made for assembling hobby projects, maybe some client boards, or even to use it for your own Tindie store PCB production runs. A small and lightweight pen holds commonly available suction needles. Therefore, it can lift very tiny and also very large components. A thin and flexible silicone hose lets you forget that it's even connected. The tactile RGB button interface lets you choose between different modes and fine-tune settings on the fly. 2 adjustable power presets make the PixelPump either quiet for tiny parts or powerful for larger ones. The included foot pedal ensures that you have both of your hands free for the actual assembly. And depending on the mode you are in, it either drops or lifts your part. The internal plumbing features a vacuum relief valve that quickly depressurizes the system once you let go of the foot pedal. The PixelPump also has a very fine filter that prevents debris from entering the system. It's visible from the outside and can be cleaned very easily. Then there's also a reverse mode. When active, it pushes air out of the nozzle instead of creating a vacuum. This lets you clear out things like solder paste that you might have sucked in by accident. The PixelPump will be fully open source, meaning its schematics, source code and STL files will be available on GitHub once the project is finished. The pump is built and assembled in my shop here in Germany. It will be delivered in a fully 3D printed PETG enclosure. I'm currently running 2 Prusa Minis, which are dedicated for the PixelPump production. So in this live stream, we'll take it to the test and assemble 15 Pico Planets to simulate and demonstrate a small production run. The Pico Planet is a nicely designed board around a SEMD21 microcontroller. It has 3 touch buttons, a USB-C connector and RGB LEDs. BleepTrack, who designed the board, kindly provided the Pico Planet Gerber files for this stream so I could order the PCBs and components. All of the boards we assembled today will be donated to her and will be available on her Tindie store. The PixelPump will be entering crowdfunding very soon, or depending on when you watch this video, it'll hopefully be already available for purchase. To find more info about the PixelPump itself, please look into the video description.
Yeah, welcome back. I got a glass of water and you got the intro a second time. Okay. So let's go through these 3 boards here that we prepared earlier and just assemble them in a little bit less time, a little bit quicker. So let me just rearrange stuff. I tried a new camera angle here. I think that's kind of okay. So still 50 viewers. Thank you very much for sticking with me here in this demonstration. Again, we are making 15 boards, 15 PicoPlanet boards today, which is taking a little longer than I anticipated. But as I said, we are talking, or I am talking, way too much. Okay, so let's make a new board. Kind of not how I would arrange stuff if I would not have the camera running. So 5.1K. That's totally not working for me. So I think this is a lot better. 5.1K. Okay, we got 1K here. I think this is a perfect time now for cutting the tape away from the magazines and demonstrating that next time. So the 0421 is, where's my tweezers here? How is that camera angle working out for you? Oh, that's not good. Rotating a 042 component here on the PCB is kind of tricky. But so far I haven't seen any tombstoning. Could talk about the LED push buttons, please. Are they tactile with the custom manufactured? Yes. Okay, let me just finish off this board and then I'll come back to the LEDs. Thanks for asking. 10 microfarads is here. No. Where did we put the 10 microfarads? That's the one that we lost last time. Here. Yeah. I think the tape for the LDO is now long enough to kind of put it up. Oh. Yeah. Maybe one more. So yeah, let me show that to you after this board. Yeah, perfect. Okay. So LDO, we are in set C5 is 1 microfarad, which is here. Yeah, it's on Twitter, but I'll talk about that lighting there for SMD placing. I can assure you that my lighting is perfectly fine. Maybe the camera is a bit underexposed, but I'm in a super bright workspace here, which is really good enough for what I do. 1K. So we need to cut the tape and the plastic in the next one. So let's change the nozzle and get the USB. Well, actually, yeah, now let's do it like that. It's so cool to have the foot pedal for that. You need to get used to it. You need maybe 1 or 2 boards or something like that in order to appreciate the foot pedal. At the beginning, it's a little bit awkward. My Twitter handle. I will, like everything you see in here that's interesting, like links and stuff, I will put into the video description once we are finished with the project. Maybe could someone please post my Twitter handle into the chat, which is Robin7331. Okay, let's just take a second to talk about the LEDs. So yes, the LEDs are custom-made silicone. Let me get one, actually. I have them here. Here. So those are the LED buttons, and they come in as a silicone keypad. Let me focus that. Okay, so this is just a regular keypad. It has those little standoffs, I guess, that press onto something, and usually those are coated in some electrically conductive material. I think it's graphite or something, and they press onto your PCB, and I kind of don't like that. That's kind of the regular TV remote or oscilloscope buttons and stuff like that, because you never know when the buttons are actually pressed. You never know if your TV remote is not pointing in the right direction, if maybe the batteries are flat or something like that. You just don't know, because you do not get any feedback. And I kind of did not like that, so I have custom made those here. You can find them on Twitter, and also the company that made them. I designed them, obviously, and they made them for me. And those feel really nice. And if you can hear that, they are tactile. There's a button underneath. Let me bring it up a little closer so you can hear my mic. If I press the lift button, you hear that? And that's kind of very tactile. And every button has 2 RGB LEDs. If I just turn it off and on again, so you can see the animation. So I can kind of display whatever state I like onto every button. As said before, you can adjust stuff. For example, you can adjust the high level motor PWM value. If you long press on high, you go into high settings mode. I know it's kind of not focused right, and now you have reverse, which turned red, and trigger, which turned green, which is cancel or save. Now you can go ahead and fine tune your high setting. You can go ahead and long press on high and decrease it with low or increase it with high. Once you are ready and set, you go ahead and save. And that's kind of the scheme for adjusting stuff here. You can also adjust the LED brightness. I told that before. In the same thing, you long press and lift, and you go ahead and increase or decrease whatever value you have. Yeah, and that's kind of how it works. Why 2 LEDs? Because it's lit more even. Because in the middle you have your actual tactile button, and left and right of it is an LED. And also I thought, I didn't make it yet, but I thought it's going to be a nice transitioning animation. It's a very subtle detail, of course, but you can transition really nice from lift to drop when you have 2 LEDs per button. But that's kind of, you know, it's a detail. Okay, so now let me make one board without talking anything, so you can kind of see how that looks like. Let me focus. So I know this is kind of taking long, but let's rush through a few boards now. Let's cut the tapes maybe first. Okay, so what I do here is I take my tapes, take a scissors, and what I do is, if I have peeled off too many components, like all the ones you see here are actually empty except for the 5.1K, I just push them back so they are all covered. And since they are held in place by a spring-loaded mechanism, I can just go ahead and let me not cut this one because I need the tape. I can just cut them like that, and nothing happens. That's it. Now you're back on track. You can, if you want, you can also cut the tape a little bit up here. And you could do that like every, I don't know, 4 or 5 boards or something like that. Great. The cradle is kind of a new word for it. I call it pen because I don't know any better word, but cradle is kind of also cool. It is not just laid on top, it is actually held in place by magnets. But I cannot demonstrate that because that's kind of a tweak I did not too long ago, and I did not install, or I forgot to install the magnets in here. So there are no magnets, but the final version will have 2 magnets here, and it will snap into place and hold there. You can even put it upside down, and the thing up here will hold onto the base. So, great. White LEDs on the handle. Yeah, that's kind of a cool idea, but you'd have to run a separate electrical wire down the silicone hose. And it's kind of very beneficial that this is extremely flexible. It is really, really flexible. And if you attach some wire or something to it to power LEDs up front, I think it's not going to be so cool. And also, you can improve lighting just by putting a second light onto your table or something like that. I don't think it's necessary to have it on here. I drop the tweezers, of course. Where did they go? They are at some random unknown location. Oh, here. Okay. Yeah, it was not so smart to cut the tape here on this part. That's the 0402 resistor, a capacitor. Okay. A lot faster now without talking. And you can see me using my tweezers all the time, and it's just a tool you really have to have. I'm sorry, I'm really not keeping up with the chat right now, and I really have to apologize that I didn't say hi to anybody, and that's just, I'm a little, you know, carried away. I got a little carried away. So we still have 60 viewers. Wow, that's kind of cool. Thanks guys for joining. So, another board done. Let's put it aside. Take the next one, which is already prepared, as you may have seen with the solder paste. So let's rush through maybe even quicker. Bam. And if you made a few boards, like this is the, I don't know, 4th or 5th board today, you're getting used to where the components are. You don't even need to your cheat sheet. You're a lot faster that way. Okay, so we need 1K resistors here and the LED, and the board is almost done. Why you want to go the crowdfunding? Yeah, that's a good question, Stefan. I actually wanted to sell the pump just straight off my online shop. That does not exist yet, but will be eventually. But the thing is, I have to go through certification. Like this project has to be FCC, CE, and whatnot certified, and that's obviously not very cheap. And that's why I have to go with crowdfunding, because I need some way to figure out the demand for the product or the project in general, and kind of yeah, just pre-order some units so I have enough funding for the certification. And guys, this is a placed board, and I just messed up because I touched it with my elbow. So I have to replace a few components. Let me do that real quick, and then we put it into the oven, and then we have, I think, 6 boards done. Yeah, I think I have some solder paste here in my nozzle, so we can use the clean function in a second to kind of clean it. So I think that's good enough. This one maybe. Okay, so let me put those into the oven and see you in a second to kind of clean out the nozzle. How long is this stream going already? Is it? Oh, it's 1.5 hours. Wow. Okay, so the oven is preheated. That explains why the room temperature is kind of not in a normal region anymore. So the oven is heating. Let's make a few new boards. Oh no, let's show the cleaning feature. So what I do when I have a clogged nozzle, and by clogged I mean if I have sucked in something accidentally, or yeah, just touched solder paste or something with the tip, I go ahead and turn the device into reverse, and now the lights for lift and drop, they go out because it's now pushing air out instead of sucking air out in. So I just take some wipe or something, put it in here, press the trigger button or the foot pedal, and it now pushes air out. And I can already see in my wipe sheet here that I have some solder paste in here. So that's it. The nozzle is clean already. I remove the reverse mode or go back to where I was before, and I'm good to go, which is putting solder paste on a few new boards. Let's make, well, how many do we have? Like we have 3 finished, 3 in the oven, so we have 6. Let's make 4, so we have 10. And maybe we could, or if somebody would start a timer on one of the boards so we can measure how long it takes, would be nice. So let's that's plenty of solder paste on here. So that's number 1. Looking very good. Number 2. Yeah, that's not ideal. Should be in one go, actually. Yeah, I think it's okay. Number 3, and obviously if you had a panel, this would be a lot quicker. Let me rearrange that. Okay. Yeah, it's okay. Number 4. A little too much, but I think it's okay. So let's bring the camera over again. Let's rush through 4 boards and then we are 2/3 done. I mean, this is not really a benchmark on how productive you are with such a system, just because the camera's in the way and all that kind of stuff. I think this is kind of a good angle, right? You agree with that? I mean, I think it's cooler to have maybe the magazines in focus and not the board. Or you want to go, let's maybe try a close-up or something like that. Let's try that. Let's bring it all the way in. Yeah, I think that's cool. Let's put it in the board. Yeah, that's kind of, if we can focus, hope so. It's too close. Okay. Yeah. It's a little awkward, but I think it's okay. So 5.1K is up here. Another one. Then we have 1K. We have the small one, which I have to pick up with the tweezer. Sorry for shaking the camera. It's really in a small space here. Like, I mean, the camera is really up close. Oh, damn. Okay. 1 micro is here. $10 micro, and in case you don't know, it's not a problem that you do not place the components 100% accurate, because once you put them into the oven, the solder paste will liquefy and kind of, with the surface tension of the liquidy solder paste, it will get pulled into place. I mean, if you're off too far, then it's not going to happen. But if you're close, you're fine. So 3 times 1K is 1, 2, oops. 3. The LED is here. How loud is the pump actually? Is it annoying in the stream? I mean, if the camera is not pointing at the pump, I can put it a little bit further. It's not annoying. Oops, that's the wrong direction. It's not as annoying as it may sound. I mean, obviously you hear it, it's a vacuum pump, but it's not too terrible. Yeah, done. So I hope I did not miss too many questions. 55% people still watching. That's really cool. I mean, that's cool. Thanks, guys. Okay. Is there anything I missed or you want to see, or did I forget? Maybe you feel free to repost your questions if I haven't answered them. Two minutes 20 for replacing. That's kind of cool. And I had to fiddle around with the 042 component because the tape is still not long enough to stick, all the way up through the slot. I think if that's gonna be 2 minutes, I hope, if that's gonna be long enough. And just to recap, it is super beneficial to have the magazines, because I can make 15 boards as I do right now, and if I have 2 minutes and 20 for one board, that's like 22 minutes, maybe half an hour for 15, and obviously without talking and stuff, I think you can go like 20 minutes, 25 minutes, you can make 15 boards like that happen, I guess. So, and then if you had a Tindie shop which has another project which you need 10, you just swap out the magazines and go ahead. I mean, okay, you have to rearrange the solder, the stencil, the solder paste printer to make the new board, obviously. But that's what you have to do with the pick and place machine as well, right? So, yeah, again, I'm not competing with a pick and place machine. That's not possible. But for certain scenarios and for small scale manufacturing, I think this is kind of a sweet way to do it. A question you missed before was about having a trigger on the handle. Yeah, I think that's a terrible idea actually, because when you place 042 components or even bigger ones, and you have to press or release a button or a hole or something on the handle, that's, yeah, you'll be shaky. You'll be, moving the part around and dragging the part and stuff like that. I think a foot pedal is way more beneficial than having something on the handle itself. Maybe something to increase, decrease power stuff you want to adjust, not when you have a part sticking on the tip, but I just don't see a benefit in having that on the handle. It's kind of okay-ish to have that on the device, I guess. So let's make a board. Oh, I placed them already. Oh man, R6 is, oh, that's 1K, okay. We have I think I'll dump a few of the 042 ones onto my desk here, or maybe, you know what, I have so many, let's just dump them somewhere. Extend the tape, it's kind of better. I have the 042 components I unfortunately put into a magazine here. That I am trying with a different spring, and this one has a lot less of a spring force than the other ones, and that's unfortunate because it's not clamping too well here. But it's not a design flaw, it's just that I used the wrong prototype for it. You know what, let me just quickly switch over to something else because I have more magazines here. I don't know where they are, so whatever. Yeah, I don't know. Let's just go ahead. I'll dump a few here so I can pick them up next to the magazine. Sorry for the kind of boring. Okay, we are back on track. Let's bring you in closer again. Is this a kind of a nice perspective, or I guess? I think that's good enough. So how loud is the pump really on the stream? I can assure you it's not too bad if you have it here next to you. It's probably a little awkward because it turns on and off all the time, but when you are using it, you obviously press the foot pedal by yourself, and then it's not as awkward, you know, when it turns on and off all the time. Okay, done. Next board. Okay, could somebody please take another measurement? And kind of like, let me cut the tape first. Okay. All right. And 3, 2, 1, let's go. I still don't remember all of the component locations. On. Yeah, I think it's probably better to use tweezers for the USB. Okay. It was over 6 minutes. Yeah, well, I know. I mean, the last one I kind of... But I think this one was a lot quicker than 6 minutes. You want to take another measurement for this one? I'll just make a countdown so we have an accurate value. Okay, so yeah, that's what I meant. It's so discontinuous. Yeah, when you are in charge of the foot pedal, it's not awkward at all because, yeah, you kind of know when it turns on and when it turns off again. So, sorry for introducing any like stress based on that. I can assure you it's not as bad in real world as it is. Yo, hey Stefan, thank you very much for the donation. Bring your baby into bed, say good night, and thanks for sticking to the stream. Have a great night. See you soon. Okay, guys, let's make another board. The solder paste is a little off here, but I hope the oven can fix it. So if you want to take another measurement in maybe 3, 2, 1, and go. Oh damn, that's not good. Oh, I feel the pressure. It's gonna be a tough one. Oh man. Yeah. But I think honestly a 1 or 2 minute mark is realistic here. When you do a lot of boards, like if this would be my Tindie board or something like that, and I had sold 50 or whatever figure, I'd know all the components. I'd know how to pick and place them. Okay, let's make a new measurement maybe for a new board. I have to rearrange the camera, it's kind of in the way. You know what we could do is we could go into the next or the second mode, and so the pump is running all the time and just stopping when I drop the component. Maybe that's a little more pleasant for watching the stream. Okay. No, not prepared any USB-C ports. Yeah, that's gonna be a terrible measurement. Terrible run. But yeah. So let's try using tweezers for the USB port maybe. I think that's better. I think I just placed this one by hand. Okay, so 4 boards done. I'll put them into the oven and I'll be right back too. And then we have 10 boards ready, guys. So that's almost 2 hours of talking and maybe 20 minutes of assembling. But they look good. We could run through a test of all the boards on the end of the stream if you want. So those look not too bad. Yeah, so I personally also find placing components very, very relaxing, to be honest. If I didn't have the camera in front of me and stuff like that, it's kind of really cool to make 10 boards, or you know, how many you need. So the oven is running. So let me rearrange the camera a little bit because I'm shaking it all the time with my hands. Maybe just a little bit up. 2 boards side by side. We can try that. I mean, the problem is I cannot put them into the vise, but we can sure. Oh, well, I might. No, I'm not able to do that. But I can just lay them on the floor. Let's try. 6. We have 6 boards here. Yeah, and 4 in the oven, so that's 10. Let's go back to the stencil. Okay. Yeah, like I said before, if you had a panel, it would be a lot easier to apply the solder paste. So that's number 1. That's all right. Number 2. I think I have to kind of reapply this. Okay. Yeah, looks good. How many do we need? We need 5, right? So let's make 5. Yeah, wow, I haven't expected to receive any donations actually. I didn't even know that this was set up. Is it like default on YouTube or something like that? I don't know. Thanks very much for the donations. I really appreciate it. Okay, that's the last one. Pretty sure there's way too much solder paste on here. Oh, it looks good. Okay. We're almost done, guys. So is it better to have a perspective from above, or is it nicer to be close? I think it's cooler to have a close-up, right? Okay, something smells a little awkward here. Let's check the oven. No, it's on the highest temperature point. That's good. I have a... Yeah, no, it's... something's not right here. No, we're good. I got a fire extinguisher just in case. And also I have a ventilation system, which is pretty serious actually. Okay, let's put this here. You want to see the boards like that? Is that something? Maybe let's try 2 at a time. Sorry for the interruption here. Yeah, let's try that. Is that kind of what you want to see? Hello to Argentina. Thanks for joining. Still 47 viewers. Man, that's cool. I did not expect that, to be honest. Okay, let's try 2 boards at a time, and then we have 3 boards left. Let's try to make them as fast as possible. The 3 ones, these 2, let's check how well it goes with 2 boards side by side. So, let's start. So how do we do that? I think it's, I need to put them like that. Yeah, that's cool. 10. Oh yeah, no, that's in my own way here. I think that's faster to do it like that. No, that's actually it for the stream. I'll make those boards, and I mean, we can have a talk if you have more questions about stuff, but actually the main goal was to make the 15 boards and actually to kind of demonstrate this pump in a sort of production environment, but it's kind of unrealistic since I am talking all the time and rearranging the camera. But I think you can actually see how this is used, and we can try to make even faster turnaround times with the last 3 remaining boards if you wish. Yeah, let's do that. That's kind of cool. But apart from that, that's kind of it. The purpose is to demonstrate the pump, to show the pump, to talk about the pump. Yeah, the next boards are finished. And stuff like that. Okay. I really have to rearrange the tray here so I can pick them up as they come. That's what I'm doing right now. You don't have to be so smart to kind of come up with that. Okay. Oh, I flipped it. And you know what? Actually, I should be wearing ESD protection, like the bracelet kind of style, which I honestly forgot. If you want, I can show you a main board of the PixelPump itself, which, oh yeah, that's kind of a nice fact actually. I'm planning to, I mean, if the project succeeds, if the PixelPump will get, yeah, whoa, I lost the point. Yeah, if the project succeeds, I kind of plan on doing the first 100 boards just using the PixelPump. Not using any pick and place machine or PCBA servers or stuff like that, which is kind of cool, I think. Okay, so these boards are finished. So we have 3 boards remaining. Then we made 15 boards in today's stream. I mean, that's not very good for a 2-hour, time. But if I would not have chatted with you guys or not have had to rearrange the camera all the time and stuff like that, I'd be a lot quicker. And I'm not sure if it's beneficial to have a vise like that or not for this project. I'll just leave it here. Okay, so let's make another benchmark run, shall we? You want to see? Let's make one board from this perspective. Okay, is anybody ready to hit the stopwatch on my countdown? Let me just cut the tapes again. Yeah, could you please post a link maybe to the Pico Planets? Yeah, just a short notice. Those boards are procedurally generated. Like, if you take a closer look, they're really beautiful. If you take a closer look, though, you see the planets, and those 3 planets are actually touch buttons. And there's an SMD21 microcontroller, and on it, and a USB-C port. You can do all sorts of stuff with it, and those are designed and sold by Bleep Track, aka Sabine from Germany, and she has them on their Tindie store, and she was kind enough to provide me the Gerber files for, wait for it, oh, you cannot focus it, the PixelPump Special Edition. You can see it right here. And she was very generous in sending me the files, and I will donate all the boards we made today I will donate her the boards, I will donate her my programming jig and all that kind of stuff. the solder paste stencil and stuff like that, and maybe she'll sell it on her Tindie store. Yeah, I have a board here. I'll turn it on after I made the last 3 boards. Okay, so can you please take a time measurement in like maybe 5, 4, 3, 2, 1, go. Man, here. The problem is I still don't remember the exact placement of the components. Swapping the nozzle. Okay, finished. How's that? I think that's less than 2 minutes. Did somebody measure? If not, I have 2 more boards. But I think that was a lot less than 2 minutes for 1 board, which is cool. So, did we have a measurement? If not, is somebody able to and willing to? Oh, it's 1 minute and 8. That's kind of cool. Let's try in less than 1 minute. With just tweezers, yeah, well, the first problem is getting the components out of the tape with tweezers is kind of tricky. I have to lay the components somewhere else or put them in a tray, which is totally doable and no problem. And you don't have to use the magazines in order to be, to use the PixelPump. But I just found it to be a nice storage. So yeah, we can make a comparison with tweezers, but I have to put them in a tray. And I think it's kind of, it is a comparison, of course, and you may be fast with it. But what if you change projects? What if you switch to a different board or something like that? I personally enjoy using the magazines because I have them stacked in a shelf or in a box, and I just grab the ones I need. That's kind of also part of the comparison. Of course, if you need to do 100 boards and you have like 5 different components, yeah, just take a magazine and dump them somewhere if you want. If you find that cleaner or faster or stuff like that. But yeah, I don't know. I like it how it is right now. But yeah, we can, if you want, we can try and dump them somewhere and do a comparison. But let's try to crack the 1 minute mark. I feel confident to do that. Okay. Let's swap the nozzle. Okay. Drink something. It seems that R1 and R2 are missing. Oh, let's check that. That's unfair if that really is the case. And it is not. Oh yes, there's 1 board missing. This, you are totally right. That's kind of cheating. That's the 5.1K, but that's a good eye, thank you. Let's place them here and make a new measurement. Yeah, nice, thanks for spotting that. On the previous 2, now it's only this board. Oh yeah, no, you're right. You are right. Ah, those were not the measured one, the measured boards. I think. And this is something the iBomb plugin obviously makes better for you, because you can kind of check off every part you placed. Okay, let's do another measurement. Are you ready? Yeah, Jason, that's kind of a valid point here. If you have them dumped in some, you know, container or something, you'd have them flipped. Sometimes, of course, they are in random locations, in random orientations, and random kind of upside downish. And with the magazines, you always pull them out in the same direction. So that means if you are getting used to that you have to rotate it 90 degrees to the left all the time, it's a lot quicker than first to determine in which direction you have to rotate them or not. Especially with components like the LED, which has 4 pins because it's an RGB LED, and it has 4 orientations that you could place them. And right now I only have to figure it out once, and then I just place them as I did last time. If you have them in a tray, it's kind of a nightmare. Yeah, and the thing is, I said that before, the cartridge kind of style is using the tape as it is designed for. The pick and place machines, the big ones the industry uses, which these tapes are kind of made for, those use them exactly like that. They dispense them out of some kind of reel holder, just like here. So every component you can buy in a tape is kind of optimized for using it like this. Okay, enough talking. We have 2 more boards. Let's make 2 benchmarks out of that. Maybe we can crack the 1 minute mark. Okay, are you ready in 3, 2, 1, let's go. Yeah, that's not gonna be a perfect one. Shoot. So C4 is 1. Yeah, that's not a quick run, to be honest. But we have 1 more. I think we are already past the minute, just as it feels. Okay. Yeah, we're done. That's not even, I think, not even close. Okay, so one more to go. Hopefully we can increase the productivity here. Do we have any questions? Let's see. Yeah, the LEDs. That's kind of the thing. And I think even with just resistors and stuff, you just have them upside down all the time, and in random like rotations and stuff. I think the major downside, obviously, like everything has a downside, right? The major downside of the magazines is kind of that you have to pick them up, you know, way above your board. But I haven't found this to be a huge like con point. I don't get like my fingers are not hurting and stuff. It's okay. I mean, if you are doing like 500 boards in a row, might be an issue, but I don't think it's, you know, I think it's still worth having stuff in this kind of style of container. And I don't see the problem in having to pick them up here. What I'm doing is I'm doing it like that. If you want, we can do the last part as you see it here. Maybe that's kind of cool. Yeah, well, so I think 1:11 for the last board. I think honestly, if you take 1 minute and 30 seconds to assemble a clean board like that, that's kind of cool. I think if you pay yourself, let's say, I don't know, 60 an hour, that's kind of $1. Yeah, what did I say? 1 minute 30, that's kind of $1.50 or something in per board for your own labor, which is, I think, all right. I mean, this board does not have too many components, of course. We have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like 16 components. If I look at my board for the PixelPump itself, let me bring that up. It has a lot more components, of course. Where is it? And you're gonna take longer, that's for sure. But I still think it's okay to make a prototype run, or I don't find the boards. Yeah, okay. Yeah, I still think it's worth making a prototype run out of them, or you know, assembling. Oh, here are the boards. A few units. I think that's perfectly fine. So is there anything, I got the boards. So this, by the way, is the board that's behind the LEDs. Let me bring that up. Oops. So this board kind of goes here. It's inside of here. It has, it's connected with a flat flex cable to the main board, and it has a push button for each silicone button with an LED left and right of it. So that's kind of the UI module. And I'm also placing it, I mean, that's a easy part for placing with the PixelPump itself. And this here is the main board. It's not the final version. This is still the STM32 version. It's not the Raspberry Pi Pico version, which is in here. So this has a lot more components, but it's still, I think I built it in, I mean, it's not a good measurement to take the first or second board, because you need way longer than for the 10th board. But I think you can do it in like 10 or 15 minutes or something like that, maybe 10 minutes. I will tweet about that once I made like 10 boards or something, once we are in crowdfunding. Yeah, not too bad. Yeah, 1:11 is not too bad. I think so. If you can make it in 1 minute, it's $1 at a $60 an hour rate. I mean, of course, PCBA and and pick and place machines, they have their place. Of course, I'm not replacing them. And the thing is, if you have a pick and place machine or a PCBA service, you can use your time for something else, of course. It's not that you have to wait in front of the pick and place machine, although it's very pleasing to do so, but you don't have to wait there until it's finished. You can do other stuff. That's kind of the main benefit, right? And also because it's way faster, but yeah. But if you do 10 boards at a time with a pick and place machine, I think it's very inefficient, because you have to set it up and configure and load the file and, you know. Okay. So let's do a last, let's do a last benchmark run, and then I'll put them into the oven. And then we have all our 15 boards that we have planned today. Okay, are you ready taking the measurement? Okay, so my problem is I still don't remember all of the components. That's kind of my problem. Okay, so let's go in 3, 2, 1. Okay. Oh no, flipped it. Yeah, that's screwed already. It's screwed already. Damn. I guess I'm not supposed to say damn. And I did not prepare the USB-C. Okay, well that's, yeah, you said it. I didn't look. That's bad. Okay. All right, I'm done. Okay, that's not a new record. But we had 1 minute and 8 seconds, which is kind of cool for a board. So let me put those into the oven, take the other ones out, and if you want, let's have maybe a chat for the next couple of minutes until the boards are finished and we kind of reached the goal of the stream in making 15 boards. I mean, the one thing that we kind of we may want to check is if they are even, if they work. I mean, that's kind of the criteria, right? They should work. Otherwise, it's not a real successful production run. But to be honest, I still find it kind of cool that we managed to build 15 boards today. Yeah, it's 122. Yeah, I knew that. I mean, it still isn't bad, right? I think if you had a, yeah, if you take like, if you take 1 minute 30 seconds overall across like 15 boards, it's fine, right? So, still 41 people watching. That's so cool, really. So let's take a look. I say those do not look too bad. You know what? Let's arrange, maybe we can arrange it on the microscope so we can take a few samples. Bring you over here. Oh, I think the cable isn't long enough. Maybe it is. I think that's okay. How well can you see that? USB problem, yeah. Kind of like. I cannot tilt it any further, that's a problem. Yeah, that's not ideal here with the microscope, but looks kind of okay. I don't see any shorts for this board. Solder paste seems to be fine. Let's look at some of the recent ones. Yeah, this one here is, I think it's bridged. Maybe it's intentional. Oh, I forgot C5 here. Yeah, I mean, look, this is because I'm rushing way too quick through the boards with the camera in front of me. This looks good. Yeah. So, are there any questions I did not answer? I'm really sorry for the camera work here. It's just that I only have this one set up right now. So like I said before, it's not mandatory to use the magazines in order to use the pump, but I think it's a great combination. Oh yeah, and by the way, look, I told that in the intro, but you have this little filter here. Yeah, I was using C5, that's correct. But like I said, this is not really a 100% benchmark because I'm talking and I'm having the camera and stuff. And usually I just take 10 seconds more to make a board. Yeah, so we have a filter here. If you accidentally suck in, some debris, or if you suck in very small components through the bigger nozzles, you can just open up the filter, take it out, clean it. That's it. You will not have anything entering the system, which is important because it'll, if you like those vacuum pumps and the valves and stuff, they will not close properly anymore if you have solder paste sticking in there. You will not get a high enough vacuum anymore if your pump isn't clean. Yeah, that's kind of what I'd expect from such a product, to be honest. And I didn't see other brands or products or whatever using that. How many beers were harmed in this process? Unfortunately, 0, but that's kind of a good idea. So, you want to see the intro once more? How many of you, yeah, that's kind of not a question that you might answer properly, or are there people that have not seen the intro yet in the chat? There is an intro that I kind of pre-made, and by the way, I finished the intro I think 7 minutes before the stream started. I started this afternoon and I finished a few minutes before the stream started. Yeah, that's a good question. Yes, it is. It will present itself as a keyboard to a PC or to a Mac or something. And the plan is to send, because right now iBomb accepts key presses, right? You can, I'm not remembering it. I think it's Shift N or something like that. And it'll hit the checkbox on placed and jump to the next line, which is what you want. And in the first version, I'll just make the pump able to submit key presses. And they will be configurable. You will have a setting here. You can enter a setting if you are in lift, long press, and a drop long press. You will have a secret menu, which is not displaying right now. Here you can start the firmware update process, so it will now enumerate as a USB mass storage device. And you can just put in a new firmware. But you can also put it into a settings mode where it will expose a mass storage device having a settings.json file, which you can use to configure the device from your PC. And you can also set what the second foot pedal does. You can make it, let's turn it off and on again. You can make it switch modes, you can make it toggle low-high, you can, you know, do whatever you want, but you can also set the shortcut it simulates or makes when you press the second foot pedal, which could be skipping one entry in IBOM or going back or something like that. Yeah, that's part of the reason why the stream started a bit late. I kind of was almost done, and I made the decision to finish it or to scrap it, but I thought I'd be able to do that before the stream starts, and it was really close. Oops. So the last boards are finished. Let's open up the tray so they can cool down, and we have successfully assembled 15 boards. Those have yet to be tested, of course, and I will do that off camera because I kind of haven't set up yeah, the command line tool for that. I cannot remember exactly where I put it, but I will tweet that, how many of them were successful. Maybe one last thought about the programming tool which I use, and I explained before. I made this, which consists of a green PCB that kind of exposes some pogo pins here, up here. They're like spring loaded, and they press onto the SWD test points here, and they're used as a back pressure kind of to press against the lever. So you just put it in here, put it down, and that's it. And you hit the command key at the command line tool, and it'll flash it, and it'll make sure it works. And this is connected to a tie guard, which is a really nice SPI, I2C, SWD, JTAG, stuff like that. It's a cool board. I backed it on Crowd Supply. Yeah, so those things, like the programmer, not the tie guard, but the programmer itself, and all the boards we made today will be donated to Bleep Track, and maybe she'll put them up on her Tindie store, because she is the original designer of the Bleep Track boards. I was actually planning to have a Bleep Track switch scenes in OBS, but then I discovered I actually programmed it, and the Bleep Track itself did work, but OBS on my Apple MacBook M1 is not supporting key commands right now, which is ridiculous. But that's why I didn't use it. Yeah, so it simulates a keyboard. That's right. Okay, so feel free to leave the stream right now. I'll bring up the intro once more if you want to watch it, if you haven't seen it. Otherwise, feel free to look into the video description if you want to know more about the pump and about the project. I'll put in the links in there. I put in the links to Tindie and everything else. If you have questions, feel free to ask them. I'll just bring up the intro and bring myself a new beer. If there are any questions or something like that, we can go ahead and take another few minutes to talk about whatever you are interested in. Yeah, so let me start the intro and see you in, I don't know, how long it takes it? 2 minutes or something like that? Yeah.
This is the PixelPump. It's a vacuum pump designed for manual picking and placing SMD components onto a PCB. It has the size of a small soldering station and is designed to sit on just about any electronics workbench. It's made for assembling hobby projects, maybe some client boards, or even to use it for your own Tindie store PCB production runs. A small and lightweight pen holds commonly available suction needles. Therefore, it can lift very tiny and also very large components. A thin and flexible silicone hose lets you forget that it's even connected. The tactile RGB button interface lets you choose between different modes and fine-tune settings on the fly. 2 adjustable power presets make the PixelPump either quiet for tiny parts or powerful for larger ones. The included foot pedal ensures that you have both of your hands free for the actual assembly. And depending on the mode you are in, it either drops or lifts your part. The internal plumbing features a vacuum relief valve that quickly depressurizes the system once you let go of the foot pedal. The PixelPump also has a very fine filter that prevents debris from entering the system. It's visible from the outside and can be cleaned very easily. Then there's also a reverse mode. When active, it pushes air out of the nozzle instead of creating a vacuum. This lets you clear out things like solder paste that you might have sucked in by accident. The PixelPump will be fully open source, meaning its schematics, source code and STL files will be available on GitHub once the project is finished. The pump is built and assembled in my shop here in Germany. It will be delivered in a fully 3D printed PETG enclosure. I'm currently running 2 Prusa Minis, which are dedicated for the PixelPump production. So in this live stream, we'll take it to the test and assemble 15 Pico Planets to simulate and demonstrate a small production run. The Pico Planet is a nicely designed board around a SEMD21 microcontroller. It has 3 touch buttons, a USB-C connector and RGB LEDs. BleepTrack, who designed the board, kindly provided the Pico Planet Gerber files for this stream, so I could order the PCBs and components. All of the boards we assembled today will be donated to her and will be available on her Tindie store. The PixelPump will be entering crowdfunding very soon, or depending on when you watch this video, it'll hopefully be already available for purchase. To find more info about the PixelPump itself, please look into the video description.
Yeah, welcome back. Could you actually hear me getting a beer? Or was the mic muted? Wasn't sure. So our last boards are finished. We now have 15 Pico Planets. I think 1 or 2 are missing a few, or not a few, but 1 or 2 are missing a component or 2. And I think that's fixable. Yeah, so guys, do you have any questions remaining? Otherwise, I'd kind of call it a day right now. How much time do you spend post-processing? Yeah, there's, like this one has, except for removing the supports. And I have 2 parts that have many supports, like this one here, which has to be optimized because I only need the bridge right here. It only needs support in the middle. It does not need support the entire length, but like post-processing is only consisting of that. There's no post-processing on the surface. I think it's a perfect surface. Like if you have the device in hand, it's really, I think it feels good. So I'm looking at 24 hours print time for a single device. I have 2 printers, so that's 12 hours for 1 unit. Sounds like a lot, but I mean, you know, if people are interested, if people are buying it, the PixelPump, I'll just buy more printers. That's it. That's a cool thing. And another cool thing is that because this is 3D printed, I can optimize and change it over time if needed. I mean, I'm hoping this is kind of the final version, but you never know. And maybe the Raspberry Pi RP2040, I don't know, will get, you know, they will stop making them, so I have to make a new PCB with a new controller, maybe need a new screw hole location. I can just change the file and print. And if I had an injection molding process going on, that will be extremely costly. It'll be extremely expensive. And also, if I had a new idea for a new project, which I do have, to be honest, I can use my same print farm to print just a different part. Or if a part fails, I just print it again. It's flexible. I love having 3D printers. I love the idea of having 3D printers making like real world products, like end user products, which this one is intended to be. The only thing is that I think if you have a product like that, or if you have a product in general and you want to 3D print it, you have to have a certain like user base to do that. Like for example, if you had a TV and you'd have, like, you'd be Samsung and you'd sell a TV with a 3D printed remote, people are gonna complain about the, you know, surface finish. It's obviously not as good as an injection molded part. But I think in kind of like this scenario here with electronics tinkerers and, you know, stuff, people like that, I think it's fine, because the same for my Prusa mini printers. They have a few 3D printed parts, and it's more than fine for me that that is 3D printed. You don't have to have injection molded parts everywhere, in my mind. Also, I can open source the STL file, which I will do, so people can, if they need, print replacement parts or modifications or, yeah, you know, stuff like that. Yeah. Well, so no supports. Yes, I mean, like I said, I only have very few parts that have supports. Most of the parts do not require supports. I just pop them off the build plate and I'm ready to go. I'm ready to assemble. This one here has to be optimized. It doesn't need that many supports. But yeah, that's an easy task. And that's also something, a great advantage of like producing something like that in a 3D printed environment is you can change those things while you are producing the project, right? So if I start making those and I see, look, I'm into the 20th pump or something, and I wanna, you know, that's not very efficient here to remove all the supports. I can just change it and the 21st part will be optimized. If I had injection molding going on, I'm like committed to the design. Oh, hey, Bleep Track, nice to see you here. Yeah, I'm still going on, and I made 15 boards. By the way, this is Bleep Track who designed the boards. I'm sure most of you have heard of her or even seen her boards. But it went pretty well so far. No LCD to see the values. Absolutely none. I have a strong opinion about, I personally believe, let's put it that way. I personally believe that there's a hierarchy starting from a push button up to a touch screen like display. I think it's, or I personally like the bottom-up approach. I hate products that put a display, or even worse, a touch screen into the product itself just to be able to say it has a touch screen. It's kind of ridiculous. If I had a touch screen on here, I think it's not as nice to touch, to you know, to press the buttons and stuff as it is here. I think those silicone buttons with the tactile button underneath with the LED lighting, it looks nicer in my mind. There are, of course, products that should have or require an LCD like a display, no doubt about that. Like a smartphone, for example. I don't want to go back into the Stone Age of having smartphones or phones without a display or without a touchscreen display. Yeah, but you know, there are a lot of 3D printers out there that have crude and not really nicely implemented LCD displays, touch displays. It's awkward to scroll a list. I love the Prusas having the rotary encoder to scroll a list. It's nice that they have a display, but it's awesome that they do not have a touch display in my mind, because you don't need it. If you have a touch display, you have to optimize every table, every button has to have a certain height and a width so you are able to touch it. If you have a scroll wheel or something like that, or physical buttons next to it, you can make them smaller. You can make the UI more efficient. Well, that's at least my way of thinking about touchscreens. It was it JLC PCB or PCB? I think it was PCB Way offering the resin print. But to be honest, I like to do it by myself. I like every single thing here, every single PixelPump. I really enjoy building them. I'm kind of I'm really looking forward in starting the production because I love printing them. I love assembling them. I love, you know, the packaging and putting them into a box and stuff. I kind of like that. I don't know. I enjoy it. At this point in time, I'm really looking forward in making every single PCB for the PixelPump with the PixelPump. I mean, depending on how well this sells and how, you know, I don't know. I mean, but I'll certainly do the first 100 or something with the PixelPump itself. And I love producing them in-house as well. If I had the budget, I would kind of investigate how I could do the silicone buttons on my own as well. Heck, I'd even buy an injection molding machine to make the magazines myself. If that's, you know, if this is kind of gonna go this way in terms of the demand and stuff, I'd be more than happy to do that. Yeah. Sacrificial layers to avoid supports. I'm not sure what you mean by that. I mean, if you take a look at this here, if I can focus. This is, let me show you the part in real life actually next to it. This is kind of the side wall here, right? So the front is covered by this front plate here, and above, like the two things here, are the pen rests, as I call them. And this is in here, and the side wall here is kind of this one. It's that one here. This is kind of yeah, a part of this. So I have to support it because I'm printing it in this orientation. It's PETG. I have to print it on the structured PEI sheet. It's printing in this way up. So how would I support that with a sacrificial layer? The only thing I can do is I do not need, those are the spray on or paint on supports from the Prusa slicer. I think it's enough to just have them in the middle. I don't need the entire length, which will prevent the support from touching this wall here and that wall here, and will be a lot easier to remove. That's kind of an optimization I can do anytime, even when I started producing the boards. This is, by the way, where the vacuum pump will go. Do you farm out the manufacturing of the silicone keypad? Yes, I do. This is made from a company in China. I found on Alibaba. A very nice contact person I had there. They were very, very nice, very helpful. I ordered a pack of samples to get a feel for their product. I kind of designed them in CAD and made the labels in a vector tool. I use Figma for that. And yeah, I ordered them from this company because I just do not see a way for me to make this of a quality of a silicone button. The quality of those buttons is insane. Like the DPI of the print, it's super nice. The silicone itself is perfect. It's a really nice set of buttons here. What's the best place to keep up with the development and production of the pump? Do you perhaps plan to cover the design and development in detail in future videos? Well, I certainly, but I mean, if this is a live stream people enjoy, I'd be happy to do more live streams and build, and update you guys about the pump and stuff. I think the best place to keep up to date is just to visit pixel-pump.com and just subscribe to the newsletter. I'm not spamming you guys with informations. The first newsletter I have written was this afternoon informing about the live stream. The link is in the video description as well. So if you want to keep up to date, just go there. But if you want to be more on like the edge of things happening, I just suggest follow me on Twitter. I think that's the easiest kind of thing. I haven't done a YouTube video in a long time. That's because I'm really busy. I was really busy in my day job. I was really busy. I had a kid. It's a little over a year old now. Lovely kid, a lot of work, takes a lot of free time, of course. And I was busy making and building the pump and the electronics and the magazines and, you know, all of that stuff. But I am super happy to make a YouTube video which is not related to any of this stuff in the future. But I mean, that's not what you asked, right? You wanted to have the update. Yeah, I'll certainly do. I mean, I enjoyed this. Is my first live stream, actually. I was on the CNC Kitchen live stream with Stefan a couple of times, but this is my first own live stream, actually, and I kind of enjoyed it. I have to really overthink my camera setup because it was a bit tricky. Yeah, I mean, like, I'm super happy to talk about the design and stuff of the pump. I mean, it's gonna be open source anyway, so there's no like secret I can or I want to keep or stuff like that. Can you write in the chat the model of the controllers that are now on the table? Yeah, well, that's, you mean those here? Yeah, I forgot to put the link in the description. I have to do that after the stream. But can someone please post a Tindie link to, or bleep track, Sabine, if you're still here in the chat, please feel free to post a link to your products on Tindie, because they're really cool. And like I said before, I'll donate them to Sabine, and if she wants, she can put them on Tindie as well. Those are actually not the ones you can buy. Those are the ones I ordered, but she has a cooler version, to be honest, in blue and stuff like that, where her art is kind of, I mean, it looks cool in black and silver, but I think I like the blue, and I think it's blue and the Enik gold finish, if I remember correctly. They look really cool. So please, could somebody post a link into the chat? I hope it's possible. Only mods can post links. Okay, well, congratulations, you are now a mod. Please post the link, that would be really nice. No, I mean those that lie in a black box. I'm not sure what you mean, like those ones here? Those are just the SAMD 21 microcontrollers. They were delivered from DigiKey like that. I mean, it's to be honest, it's a ridiculous kind of tray. This is a serious injection mold, the plastic part here. Would you consider selling an injection molded version of your parts feeder? Yes, absolutely. This is kind of the next project. By the way, I think I said it in the intro. The PixelPump, right now I'm in contact with Crowd Supply in terms of the crowdfunding approach for this. And I think it's gonna be on the platform soon. And for the magazines, I actually thought about, I have a whole bunch printed out. I think I got about 100 magazines lying around waiting for, for their use. I kind of thought about if somebody's interested, I'd kind of just start selling those as a 3D printed version. It's kind of a 3-part solution, to be honest. There's the rail, which is, here's an empty rail. It looks like that. It kind of has this foam here, which is providing just enough back pressure against the magazine to be held in place firmly, and this is really, it's in there really nice. And the thing is, I have a video up on YouTube explaining the version 1, which like this mechanism hasn't changed. So if you want to see more about that, just go to my YouTube channel and look for the video of the version 1. But this rail, actually you click in the magazine like that, and the compliant mechanism lever kind of latches in here behind, and now you have a stand for the magazine. And the magazines itself, I have shown that before, I think, but let me just take the camera over here. I have a whole bunch of magazines which are already labeled and filled in with stuff, because I kind of do not like having them like that, which you get them from LC, SC, or DigiKey. You'll never find the component you want. Like imagine finding a component in here versus finding a component in here. Yeah, so if you're interested, I just put up a landing page, and I don't know, maybe start selling them before I am at the injection molded version of it. I mean, it should not be a huge difference for you to use them in a 3D printed state, because it doesn't matter actually. The only difference is that it's very inefficient to 3D print this part. I will not make a huge cut on them if I offer 3D printing, or if I offer them in a 3D printed, state like that. The rail will be 3D printed. I thought about having an aluminum extrusion, because it kind of is a perfect part for an extrusion, and it also had enough weight, but I think I'll just stick with 3D printing for the beginning. By the way, those are sand filled, same as the PixelPump. Like the entire base is full of sand, so it's relatively heavy and sturdy, because you do not want a moving like rail with the magazines when you are placing components. So that's kind of cool. So maybe I'll set up a landing page and just, I mean, this is not to make a huge profit. This would be for gaining just a little financial, just little, extra to maybe buy 1 or 2 new 3D printers to kind of hit the ground running once it reaches crowd supply or something like that. Oh yeah, and there's another tool which some of you may have seen, and the magazines have a problem, or I mean, it's not a problem, it's how they are designed, and it's how, I don't know, physics work maybe. If you have a magazine like that and you want to fill the tape all the way, like if you want to fill it up all the way, just like this one here, if you pull that out, you will not be able to push it in after a certain, like it's blocking itself right now, because it tends to expand in the magazine itself and pushes outwards and kind of blocks itself from going in. Like I'm not able to push it in here. Maybe I can push it with a centimeter more or something, but I'm certainly not able to fill up the entire magazine like it is right here. So I came up with a kind of little mechanism here. Looks like that, looks kind of creepy. But you can go ahead and you just click a magazine on here, and it attaches with some spring-loaded levers. So the thing is, you can put your SMD reel here. Let me actually, why not? Let's fill one up. I have one here without a side, so you can actually see what's going on. So look, this is how it works. You put it here, you put your magazine here, and those 2 spring-loaded levers are interlocking with the magazine. So this is attached here. So now you would go ahead, let me grab a spool. So here we have a Samsung 100 nanofarad 0603 capacitor. You open up here, and this is not a final design, this is just a proof of concept, to be honest. But you open up here, you put the spool on here. If you want, you can lock it. So it's not it's wobbly, but it's not falling out. It's wobbly because it supports different spool heights. You go ahead, And this is going to be a terrible example because this magazine is open and does not have, yeah, no, that's okay. It does not have, so. I didn't put a spring loader in here, but let's try it anyways. This here is, you can put it like that. Now you can unroll the spool by jogging the wheel here. And this is going to be a terrible example, I guess. No, it's working. Yeah, you can hold it like that. It looks awkward, but it's actually pretty cool to use. You can go ahead and you can wind up your magazine all the way until it is full. And I made it stick out a little bit too much. Yeah, but it's okay. Like that, you take the tweezers, you cut off the tape, and you're good to go. And you loaded in like 1,000 components. And that's like the Pixel Planet has, for example, you need 2 5.1K resistors per Pixel Planet, so you can build 500 Pixel Planets of one magazine until you have to refill it again. Yeah. So that's how it works actually. And then you go ahead, you just hit the 2 levers here, pop it off. That's it. You have a filled magazine. It's kind of how it works. I mean, you don't need it for every project, right? Because it is upside down, and that's because it's. I put it in. I put the spool in the wrong direction, but it doesn't matter actually. And no, you mean upside down is if the end it should enter here. That's not a good idea. I tried, but it's a lot better to have a loop here to kind of not flex it too much and to bend around the corners. If you have it here, it didn't work too well, to be honest. But yeah, that's kind of how it works. I mean, sure, you have a little bit of overhead. If you have, I mean, you have probably maybe 5 or 10 components that you need very often, like just decoupling caps, like 100 nanofarad and stuff like that, or pull-up resistors. I mean, yeah, you'd have to refill the magazine from time to time. But I don't think that's huge of a downside, to be honest. At least I have, I think no, which one is it? I have it for ages. I never ever filled up a magazine. But of course, it depends on how you use it, right? Yeah, so that's the mechanism, which you probably need. The parts are upside down. Yeah, you're right, but this is kind of just an example. This magazine is not even closed. It's not. I'm not using it for this. I have a magazine filled up with 100 nanofarads. I just pulled out the reel to demonstrate. But you're right. The parts are upside down. The tape is on the wrong. The tape is below. That's not how it should be. Yeah, you're right. But as said, it's just an example. For example, look, let me bring up a... Let's look at my box here, which I have for various things. Look, this one here is a 100 nanofarad one. It's also a prototype magazine, not the final version, which is only partially closed, but does the same thing. And it lasts a long time. I mean, sure, it depends on how many boards you actually make. If you really need one component like many times, sure, maybe the magazine is not the right storage solution. But I think most of the components, it's actually pretty convenient to have them in here. For example, if your only board is a board that has 1 resistor and let's say 50 LEDs, yeah, well, not sure if you need 2 magazines for that. Probably yes, because we had it before, like, right? You know the parts orientation because it comes out of the magazine always at the same angle and, you know, direction. So it's kind of benefit. John, you asked about the filter, I remember. Yeah, it's a sourced part, and it took long to find it. Let me show you. It's a brand I think it's relabeled. It's a brand. It's called Really. They're pretty expensive. Like the one filter, I mean, expensive for my production or like for my project here. I think it's the most expensive part, to be honest. It's $5, €5, and yeah, I got them from a German company. I'm not sure how well or how they sell overseas or something like that, but it is the perfect filter for this because it has the right diameter. It is so small that it's not interfering with anything. It's almost in line. It's perfect. It's a really nice filter. Isn't really from Conrad? Yes, it is. They sell them on Conrad. Can't be cheap then. Yeah, that's correct. But I bought them from Völkner, which is also a German shop. But I think it's the same brand. I couldn't find the original manufacturer. I had to buy the rebranded Conrad kind of product. But it's so good. It really is good. And because, let me bring that up once more. It's so tiny. Can I zoom in again? Conrad, yeah. Explains the price, correct. This is actually a gasoline filter for an RC, model airplane or car or something like that. And why it is so good for this purpose is because the focusing is really off today. Sorry for that. It's a sinter filter, right? So it has a lot of small part, like, what is it? What's the material? I think it's a copper blend or something. They are sintered together to form a filter. And if you suck in any debris, it'll be just in this glass piece here. It's not glass, it's plastic, but in this like translucent piece. And you can go ahead and really easily just flush it out with alcohol or whatever you want to use, and you are back on track. And it's very small. Yeah, and it's almost hidden in line here. Oh yeah, and by the way, the silicone hose, it's a great product. It's from a German manufacturer. It's heat resistant. You cannot break it with your soldering iron at regular temperatures. I mean, if you leave it there for an afternoon and at 400 C, of course. But at like 250 C, nothing happens. And I have a cheap vacuum pump. Yeah, let me bring that up actually. Of course, I searched for finished vacuum pumps before I decided to build my own. Where is it? Oh, I cannot find the silicone hose. It's either extremely sturdy, and if you have a sturdy hose like that, and you drag across your pencil across your desk, you'll hit everything. And the other one, you burnt a hole in it when you touched it for half a second with your soldering iron. Völkner is also Conrad. Okay, I did not know that. Yeah, but it's from there. Really, I never heard about that brand before. Okay, guys, I think we're good for today. I am exhausted. I want to enjoy a beer or the remaining beer. We are into the stream 3 hours now. We built 15 Pico planets, and yeah, I think that's cool for the first stream. Okay, guys, thanks for joining. Really, I will start the intro once more. Feel free to leave the stream in case you haven't seen the intro. It kind of explains the entire product once more in 2 minutes. So if you haven't seen it, feel free to watch it again. Otherwise, you can Please follow me on Twitter if you want to have updates about the pump, or go to pixel-pump.com to get updates about the progress on crowdfunding and the availability. Yeah, maybe see you soon, hopefully, on another live stream talking about PCBs and pixel pumps and magazines and whatnot. So, I guess see you then. Well, you're very welcome. And see you next time, guys.
This is the PixelPump. It's a vacuum pump designed for manual picking and placing SMD components onto a PCB. It has the size of a small soldering station and is designed to sit on just about any electronics workbench. It's made for assembling hobby projects, maybe some client boards, or even to use it for your own Tindie store PCB production runs. A small and lightweight pen holds commonly available suction needles. Therefore, it can lift very tiny and also very large components. A thin and flexible silicone hose lets you forget that it's even connected. The tactile RGB button interface lets you choose between different modes and fine-tune settings on the fly. 2 adjustable power presets make the PixelPump either quiet for tiny parts or powerful for larger ones. The included foot pedal ensures that you have both of your hands free for the actual assembly. And depending on the mode you are in, it either drops or lifts your part. The internal plumbing features a vacuum relief valve that quickly depressurizes the system once you let go of the foot pedal. The PixelPump also has a very fine filter that prevents debris from entering the system. It's visible from the outside and can be cleaned very easily. Then there's also a reverse mode. When active, it pushes air out of the nozzle instead of creating a vacuum. This lets you clear out things like solder paste that you might have sucked in by accident. The PixelPump will be fully open source, meaning its schematics, source code and STL files will be available on GitHub once the project is finished. The pump is built and assembled in my shop here in Germany. It will be delivered in a fully 3D printed PETG enclosure. I'm currently running 2 Prusa Minis, which are dedicated for the PixelPump production. So in this live stream, we'll take it to the test and assemble 15 Pico Planets to simulate and demonstrate a small production run. The Pico Planet is a nicely designed board around a SEMD21 microcontroller. It has 3 touch buttons, a USB-C connector and RGB LEDs. BleepTrack, who designed the board, kindly provided the Pico Planet Gerber files for this stream so I could order the PCBs and components. All of the boards we assembled today will be donated to her and will be available on her Tindie store. The PixelPump will be entering crowdfunding very soon, or depending on when you watch this video, it'll hopefully be already available for purchase. To find more info about the PixelPump itself, please look into the video description.